Hey everyone, and welcome back to the channel. Today, we're diving deep into the architecture of a system designed to tackle a crucial challenge when working with powerful AI models, specifically large language models, or LLMs. You know, models like the ones that power chatbots and generate creative text? Building cool stuff with them is one thing, but how do you really know how well they're performing? That's what this system helps us with. Take a look at this diagram. This is the blueprint for a robust platform that lets us generate outputs from LLMs in batches and, just as importantly, evaluate those outputs systematically. Let's break it down, piece by piece. It all starts with the users over here. We interact with the system through a secure frontend. This frontend is likely running on something like an ECS cluster, that's Amazon's Elastic Container Service, which is great for running our application in a scalable way. A load balancer sits in front of it, making sure traffic is distributed efficiently and our system stays responsive even under heavy load. Now, when we want to do something, like generate text or evaluate results, our request goes through the API gateway. Think of the API gateway as the main entrance for all external interactions with our backend services. It's secure, it handles routing, and it connects our frontend to the different parts of our workflow. Let's follow the batch generation path first. When we want the LLM to produce a bunch of responses based on a set of prompts, the API gateway triggers this AWS step functions workflow. Step functions is awesome because it lets us define a series of steps visually and manage complex processes. Inside this generation workflow, we first fetch things like our prompt templates. These define how we structure the questions or instructions for the LLM. We also grab our datasets, which contain the specific inputs we want to use. Then, the workflow generates the final prompts and invokes the LLM itself. In this diagram, it shows integration with Amazon Bedrock, which is Amazon's service for accessing various leading foundation models. The LLM does its magic, generating outputs. Finally, the workflow handles any necessary post-processing of those outputs and saves the results securely into an S3 bucket, which is basically cloud storage. Okay, so we've generated results. How do we know if they're good results? That's where the batch evaluation workflow comes in, also triggered via the API gateway. This is another AWS step functions workflow. It starts by reading the output data that we just saved to S3. Then, it kicks off the evaluation process. This system uses an LLM evaluator, which could be another LLM specifically tasked with judging the quality of the generated responses, or a different evaluation model or script. The core of this workflow is about evaluating against required metrics. The diagram shows a loop here. We evaluate, potentially perform some post-processing on the evaluation results, and then crucially, we trigger metric factories. These metric factories are super important. They represent different ways we can measure performance. We could have metrics based on the LLM's own evaluation, LLM eval metrics, metrics based on user feedback, imagine users rating the responses, or even metrics related to RAG, retrieval augmented generation, if our system is pulling information from external sources. Each factory processes the data to produce specific scores or indicators. After the metric factories run, there's more post-processing specific to the LLM evaluation results, ensuring everything is in the right format. All the datasets we use, the initial generation results, and the final evaluation results with metrics are stored persistently, likely in S3 or a dedicated result store, as shown here. What do you think of this architecture? Let me know in the comments below. Don't forget to like this video and subscribe for more deep dives into AI and cloud technologies.